This episode of Mathematics with Mr. Richardson is brought to you by Pythagoras, proudly taking credit for the work of his homies since 571 BC.
Section 8.8, Factoring by Grouping. The objective of this section, to factor higher degree polynomials by grouping. Lesson vocabulary, factoring by grouping. An essential understanding. Some polynomials of a degree greater than 2 can be factored. Let's consider this problem to get us thinking along the lines of factoring higher degree polynomials. A packaging company sells two kinds of boxes, box A and box B. The company is designing a new box, box C, that will have the same volume as boxes A and B combined. Suppose one dimension of box C is x. What could be the other two dimensions? Explain your reasoning. Well, I think we can agree that in order to solve this problem, one of our first steps should be to find the volume of box A, we'll call that volume sub A, and the volume of box B. Knowing that we combine those two to find the volume of box C. Now, if you recall, to find the volume of a right rectangular prism, like a box, we multiply all three of the dimensions, length times width times height. In this case, that will be Now, I would prefer to multiply the two x's to begin. X times x and then distribute the x squared to both terms inside the binomial. And that represents the volume of box A. Some similar work to find the volume of box B foiling first the two binomials. And then combining like terms. Before finally distributing the x to all three terms in the trinomial. To find the volume of box B. And keep in mind the problem tells us the volume of box C is the sum of the volume of boxes A and B. So if I clean up here just a bit to create some room to add those two volumes, those two polynomials, we can find the volume of box C and then set to work determining possible dimensions for that box. So, a reminder, we'll be adding the volume of box A with the volume of box B, making sure to line up like terms so that we can combine those more easily, and finding a sum of and that represents the volume of box C. So our next goal is to determine what dimensions can replace the question marks here to represent box C, and keep in mind these values, when multiplied by one another and also by x, need to equal our trinomial, representing the volume of box C. Now, one thing to note, we already know one of the dimensions is x. So our resulting factored form of 4x cubed plus 13x squared plus 9x can be written with an x factored out, where one of these two question marks can be represented here, possibly with a monomial, possibly a binomial, maybe even a trinomial, most likely a binomial. And similarly, our other dimension, or the other question mark, can be represented there. Hopefully you've already realized that the fact that x can be written as one of the factors of our trinomial tells us that we can factor x out of this trinomial. That, of course, would be the first step if you were simply asked to factor the trinomial. Recall you search for a greatest common factor, and upon finding one, immediately factor that out. So a quick double check of my work to make sure I've factored x out correctly. I'll distribute it and ensure that I get back to our original trinomial. 4x cubed, good, plus 13x squared, very good, plus 9x, excellent. Now our goal is simply to factor the trinomial left inside of parentheses. And that factored form should leave us with two factors that can represent our other two dimensions for our box C. Like we've seen in the past, the factored x will just hang out outside of the factoring that takes place with the trinomial on the right. So we fill in our first terms, keeping in mind that they must have a product of 4x squared, and selecting two factors of 4, and then factors of 9, and a quick check with a FOIL. First, 4x squared. Outer plus 4x, inner plus 9x, which when combined with our outer product gives us the plus 13x we were looking for. And last, plus 9. Very good. Notice what we have here is the factored form of our volume trinomial, and it's written in three parts. X representing one of our dimensions, for box C, 4x plus 9 representing a second dimension, and x plus 1 representing the third dimension of the box C.